Welcome back, Level 1 physicists and earth space scientists. Continue on with the heat external, today looking at the third type of transfer, thermal radiation. So what is thermal radiation? Well, basically thermal radiation is the transfer of energy between objects by infrared waves, which is a form of electromagnetic radiation, or part of the electromagnetic spectrum. Okay, so radiation is unique in the sense that it's the only heat transfer that can happen through a vacuum. Okay, and because infrared radiation is electromagnetic in the spectrum, it's going to travel pretty fast. It's going to travel at the speed of light, actually, which is the basically the universal speed limit. And gases tend to allow radiation through better than liquids, and liquids better than solids, because those particles are going to interact with the radiation. And so that means if they're closer together, they're going to interact more. So solids block radiation better than liquids or gases. So in terms of detecting thermal radiation, okay, we use things called infrared cameras, okay? And you also feel infrared radiation on your skin on a hot day, and that's why it feels warm, because the sun is emitting infrared radiation, which is now basically hitting your skin. And in terms of infrared, as you see from this picture of this woman, the red colours and orange colours and yellows mean that's the basically the sections of her body which are emitting the most infrared radiation, so emitting is releasing. And the darker colours around her feet and legs are not emitting as much, they're a lot cooler, okay? So in terms of temperature and this radiation, all objects above absolute zero give off thermal radiation. So you're giving off thermal radiation right now. And the hotter the object, the more radiation it's giving off. So if you look at the image there, you can see the hot object is emitting lots of infrared radiation, whereas a cooler object is not releasing nearly as much. So in terms of surface and release or emission of infrared radiation, dark surfaces emit radiation better than bright surfaces, which is quite interesting. Okay, so a can of hot water, if it's basically got a black surface, it's going to cool down faster than one which has a shiny one. Okay, and rough surfaces emit radiation better than polished surfaces. So in the example of the image we have here, where we have a copper plate where one side is polished and the other side is blackened, and we place our hands against it, then you're going to feel that the darker surface, the one that's been painted, will be hotter than the shiny one. Okay, so it'll feel cooler to the touch compared to the shiny side compared to the darkened surface. In terms of absorbing and reflecting, because it's a wave, okay, radiation, infrared radiation, dark surfaces absorb radiation better, so that's why a darker t-shirt always feels warmer to wear during summer, whereas a bright surface reflects radiation best. So that's the reason, for example, the polar ice caps melting is not a good thing, because that ice is reflecting back the radiation from the sun back into space and cooling the planet down, whereas when it disappears, it's going to start heating up. And rough surfaces absorb radiation best, whereas polished surfaces reflect radiation best. Okay, so that's why a shiny surface feels cooler to the touch than a rougher surface. Okay, so finally, looking at silvered surfaces. So this kettle here, the firefighter and the marathon runner being covered by a silver surface. The reason why is because it keeps the warmth in, but also keeps the warmth out. So it's quite a very useful tool, okay, because it's basically a silver surface is going to absorb less heat energy through radiation, and also it's going to basically reflect the heat energy radiation back from the body in terms of the silver blanket.